The Hartley oscillator is the same as the Colpitt's oscillator, with the only difference being in the construction of the tank circuit. The inductor is tapped. As a result, that center point on the inductor will have a 0 volt on it, and then the capacitor's voltage will divide over the two generated inductors. When we're looking at the construction, we again see our normal common emitter amplifier with base biasing resistors, or voltage divider biasing. These two resistors, when connected, will place the transistor in the active region. That voltage that it generates is fed back onto the tank circuit, causing my positive feedback, which will then in turn bias the transistor even further. The inductor resists the change in current, so as I connect the circuit, that positive voltage, or the voltage that I feed back there, will cause a bias on my tank circuit. That will cause the capacitor to start charging and the inductor to start resisting that change in current. This section of the coil is in parallel with the base biasing resistor there. As a result, I'm feeding a negative into the base, which turns my transistor more off, which in turn will cause a increase in voltage. Once that voltage increases to the point where the transistor reaches saturation, that means that there is no more change in voltage, which means my inductor will now start to conduct. That will allow the tank circuit to go through its charge and recharge cycle. Capacitor discharges through the inductor. The inductor, as the capacitor discharges, the voltage will increase again. That will turn the transistor more on, which in turn will decrease the voltage. Once the capacitor is completely discharged, the magnetic field on the inductor will cause a back EMF to charge the capacitor in the opposite direction, which means the polarity on the tank circuit reverses. That positive on the base of the transistor turns it more on, which in turn will increase my output current and decrease my output voltage. That feedback signal will charge the tank circuit in the positive negative direction again, which in turn will turn the transistor further on until it reaches saturation. Once that happens, the inductor will allow for the capacitor to discharge, and as that capacitor discharges, it then creates a back EMF, which will turn this transistor more off again, which in turn will increase the voltage. As a result, the tank circuit will cause the transistor and amplifier to generate a sine wave. The frequency of that sine wave is the resonant frequency 1 over 2 times pi times the total inductor value multiplied by the capacitor. Sometimes L1 is given as L1 and L2, representing the two halves of that inductor. As a result, we just say L total equals L1 plus L2. We only use this formula if L1 is divided into L1 and L2. Otherwise, we use 1 over 2 pi L total, which is L1 and 2 together, times C.